Hello students, and welcome to another how-to video. Today we're going to be calculating the percent yield. Okay, this is the second video in a series. The first video we calculated the theoretical yield. So if you haven't watched this video, please go back and watch the other one before you do this one, because this is just one step further from this problem. Okay. All right, so we're going to calculate the percent yield, and we're going to use the same type of problem, right? We're going to take solid calcium carbonate and we're going to decompose it into solid calcium oxide and carbon dioxide. And what we're going to do is take it a step further. We're going to ask, what is the percent yield if we collected this much calcium oxide? All right, and what we started with was 45.1 grams of calcium carbonate. Okay, so let's do this again. Let's set up our equation, and then we're going to find and kind of make a plan of how we're going to get there. Okay, so let's balance the equation. We've got calcium carbonate, that's solid, and it's reacting with heat. Okay, you can also put a triangle there. All right, and then it's going to break down into calcium oxide plus carbon dioxide gas. Okay, and it's balanced. We have one calcium, one carbon, and 3 oxygens here, and we have 1, 2, 3 on this side. Okay. And what we're given is 45.1 grams of calcium carbonate, okay? And what we're trying to find is our percentage yield of this, okay? We're trying to find that percent yield. But what we actually collected was 8.56 grams of this substance. So what we need to find is the theoretical yield first, and then we can compare it to the value that we collected in the lab. Okay, so this is something that you found, right? You put your lab together, you found this amount, but you're like, well, how close was I to the mark? You know, was I close? Because 8.56 doesn't mean anything until you start referencing it to something, and you're like, well, let's see how close we are to a perfect system. All right, so let's go down here and let's convert our 45.1 grams into moles, and then using that mole ratio to calculate the theoretical yield. All right, so we have 45.1 grams of CaCO3. Okay, we got 1 mole CaCO3. All right, we can calculate it on the periodic table, but for sake of time, we already discovered this in the last problem, and it was 100.09 grams of CaCO3. So our grams of calcium carbonate cancel. All right, and we're going to compare it to our mole ratio, which is a 1:1. So if we write this out, it's going to be 1 mole of CaCO3. We want it so it can cancel with 1 mole of CaO. All right, calcium oxide. And then we did this math before. We found the molar mass of calcium oxide, and it's 56.08. All right, so we're going to do 56.08 grams of CaO per 1 mole of CaO. These cancel. All right, and then all we got to do is crunch out the number. Okay, so it's going to be, and this number is different than the previous problem, so we're going to repunch this number in. So we've got 45.1 times 1 times 1 times 56.08. That's the top, and then we're going to divide it by 100.09 because these are just ones. And that's going to give us 25.27. It's going to be 25.27 grams of calcium oxide. That's our theoretical yield. And to calculate our percentage yield, let's just go through and write out what we have. Our actual yield was 8.56 grams. Okay, and in a perfect system, we would have made 25.27 grams. Okay, and then we're gonna have to times it by 100 so we can make it a percent. Okay, so let's do this. we have 8.56 divided by 25.27. It's 0.33, times it by 100. It's going to be 33.87%. Okay, so our percentage yield is that we only got about a third of our reactant. If we wanted to collect this calcium oxide, we should have had 2/3 more of this substance, but we only collected this much. So when you're doing this experiment, we're gonna have to find ways to refine and bring that percentage yield higher, because this isn't a good yield for this reaction. Who knows? It could be low. I mean, we may need to try it again and see if we can get a higher yield of concentration of calcium oxide. Okay? All right, thanks for watching.